All right, I think we can start. So welcome everybody to this Climate Hive Connect webinar with Elephantech. My name is Alex Guinness. I'm the Director of Content at Climate Hive. And today we're going to be talking about Elephantech and their product, printed circuit boards. So printed circuit boards are a vital part of modern electronics, from TVs to PCs to industrial equipment. But most PCBs are inflexible, have large material inputs, and a large carbon footprint. As a result, manufacturers are missing sustainability targets and wasting precious resources. Luckily, there's a new sustainable PCB on the market. We're thrilled to introduce Elephantech, a startup from Japan that is innovating design and manufacturing for sustainability. So please feel free to put your questions in the Q&A throughout the discussion. The presentation will run about 25 minutes, and we will have time at the end for your questions. Now I'd like to introduce Satoshi Konagai, COO of Elephantech. Satoshi joined Elephantech in 2021 and was appointed as COO and Executive Officer in 2022. Satoshi started his career in management consulting at EY Strategy and Consulting Company Limited in 2013, where he advised manufacturing companies on operational transformation and management system implementation. In 2016, he joined Industrial Growth Platform Incorporated, a Japanese management consulting firm, where he provided consulting services mainly to manufacturing companies. In 2020, he conducted research on growth strategies of Japanese companies as a visiting researcher at Columbia University Business School. He holds a master's degree in International and Development Economics from the Graduate School of Arts and Science, Yale University, and a BA at Soka University of America. So everybody, please welcome Satoshi.
Thank you for Alex for the great introduction. So hi everyone, my name is Satoshi, CEO at Elephantech. Thank you so much for attending today's webinar. Elephantech, we are the inkjet printing specialist and provide the decarbonization solution, which is on the title called like sustainable circuit. PCBs made by inkjet printing technology. So before going to the actual presentation, I just want to take a quick survey for Meet. So first question is like, which industry do you work in? And secondly, like what department do you work for? Okay, great. So let me jump into like actual presentation. By the way, thank you so much for attending today's meeting. So Elephantech, we are the 10 years old Tokyo University spin-off startup. We have like multiple business shareholders such as Seiko Epson, Shin-Etsu, Mitsui Chemical, Sumitomo Corporation, and Ajinomoto from Japan. And our headquarters is located in Tokyo, and the mass production at the Aichi Prefecture. So we are kind of old startup, but still we are on the phase of like expansion phase. And at Elephantech, we are making it our mission to make the world sustainable with new technology, end quote, and are committed to bringing sustainable innovation to the electronic industry. Through our sales activities, we have like heard from companies around the world about their various needs and challenges, such as challenges toward achieving net zero, reducing CO2 emission, challenges of ensuring profitability amid continuous rising resources prices, and challenges of diversifying the supply chain in response to the increasing geopolitical risk. And we are the one who can solve this issue. We can, through using our technology and the production methodology, we can reduce CO2 emission from PCB, reduce waste resources. Because our process is simple and easy to implement, our production technology provides a solution to diversify supply chain. And before the detailed explanation of our technology, I would like to quickly go through some statistics. So despite relatively small mass of printed circuit board, PCB CO2 emission are extremely large. So for example, like 30% of the CO2 of the smartphone production coming from PCB, 25% of the CO2 of laptop production is coming from PCB, and 10% of the Apple's total activity is coming from PCBs. Of course, this is coming from like LCA studies, and then some studies, I mean the numbers are varied from like statistics and also like study by study. But this shows that at least like PCBs has like a large, at least like a significant portion of like PCB emissions from like those electrified product. And this is another statistics of how PCB industry is not good for the environment, such as like a large volume of like green gas emissions, wastewater pollutions. This is because like conventional methodology on the top of this slide shows like a conventional methodology, so-called like subtractive method. And then basically like this conventional methodology is on the top of the substrate, I pile up all the necessary materials and they form the circuit pattern through the chemical process to remove like unnecessary part. That is why there's a lot of like green gas emissions from like raw material loss and wastewater pollution through the all the chemical processes, because each time like each it's going to the step by step, there is like a lot of like washing processes there, because like, there is a lot of like toxic chemicals there. And not only like environmental impact, but also like a high demand of the copper will be near-term business risk for the PCB production. So this is another statistics. So this like a left-hand side like a chart shows like how copper price increased from like a 1980 to like 2024, like the last 40 years, and then the price is actually like it's around like 5 times compare right in the last 40 years, and this trend will be continue because like the copper demand will be even higher and the supply will be even tighter due to like a future demand, strong demand for the electrical vehicle and also clean energy. So in the worst case scenario, due to like a high, I mean the very expensive like a copper price, and then together with like a high volume of CO2 emission, PCB production will be like really difficult to be sustainable. Would be like the case that the price of the PCB will be even way higher than like a current price. That's the worst case scenario we may have. That is why we produce like our like a very innovative like production methodology called like a pure additive method. So unlike conventional method, our method, so-called like pure additive method, is pretty simple. On the top of the substrate, we print copper nanoparticle ink using our inkjet printing equipment, and then base them into like a plating line to increase the copper thickness, and that is pretty simple. So they through the making a paraning, there is no removal process at all, and that is why um, our our process doesn't have like a raw material removal process, and then we can reduce like a copper usage by 70%, carbon footprint by 75%, water usage for like 95% with sustainable cost. So our production processes will be like a silver bullet to solve like a PCB industry's issues. And this is just like a key milestone, like how like our 10 years journey consisted. So we spend like around like yeah, basically like 6 years of like establishing technology in the laboratory, like experiment, and then starting from 2020 to 2022, like we started small scale mass production, and then we started like a mass production shipment in Japan. And then we spent like a global expansion phase like the last 2 years, and then we got like a tangible MOU from like various corporations like Lighton or Logitech. And then now we are shifting towards more like a larger scale mass production and also diversification of our product or I mean our product. So right now in the PCB categories, we are doing only mass production for like a flexible printed circuit. But we are right now preparing for the rigid printed circuit, which is like a different type of like a PCBs, and which has like a more demand and volume. And then, yeah, this is just like a quick summary of like a quick characteristic of like what kind of like success circuits are. And then basically like we pass all necessary quality tests, performance tests for like a mass production usage. And also we got like a certification from ISO and the UL, and also like we are complying for the regulation which is necessary for the mass production. So basically, like our product is already in mass produced, and then some of the mass produced for like the last, yeah, like 5 years. And that's the reason that the reason why like we succeed in mass production with inkjet printing technology first in human history is because all element technology are produced in house, such as like a nanoparticle synthesis, metal ink formulation, um, metal inkjet printing technology, and electronics plating, together with like I mean inkjet printing equipment in house. That all necessary technology produced in house. And then I think that this is a characteristic of inkjet printing, but inkjet printing technology requires like sophisticated matching of the multiple element technologies simultaneously. So that's the reason why like even for the startups, like we hold like every single element in-house, and then that is why like we could do like mass production with this like technology. And then we already launched like this like inkjet printing machine for our mass production line, and then we are preparing for the starting sales of like this inkjet printing technology. So once like system sales will be started, because our process is very simple, easy to implement, many customers can easily manufacture PCB with which leads to like supply chain resilience at many countries. That's what we believe. And then this is just a specification of our like a mass production. So ERP03 is that like a previous version of like our mass production equipment. And then ERP04 is now like we are it's the newest equipment for like our mass production line. And as you can see, like there are like a lot of like technological evolution for like size and then also like footprint and also like productivity. So with the newest one, like which is like equivalent to like a conventional methodologies like production efficiency. On the next two slides, we would like to show like how and what kind of like partnership we have with like our customers. So because our innovation technology, a lot of projects are going on right now, and there like some of like project can be on the allowed to be like a marketing purpose. And then I just want to show like some examples. So Logitech is one of the good example, and then we won like their Future Positive Challenge in 2023. So basically, Logitech has like various categories for like for the specific electronic component, and the PCB is one of them, and they're actively seeking for like a sustainable PCB solution, and then we won the category. And we are now discussing with like Logitech for like for how to implement our technology into their like their actual goods. And then next slide, there is another example which is showing about our MOU with Lighton. So we are mutually targeting to the decarbonize like 24 million of like out of like 50 million Lighton manufactured keyboard annually for replacing their conventional PCB to like our PCBs. That's what we are going on right now, and then we are aiming for like a fast project on the mass production for that sometimes on like next 2 years, and then we are looking for like a more project who are interested in our technology. And then this is like just quick summary of like what kind of like our technology roadmap. So now, like we are, right now we are about for the 2025, which is like our generation. So this gen is like how we evolve like our processes. So first, like mass production, starting from like a first generation of the process, and then right now we are about to shift for like a third generation of the line, and then which unable to do like more like a thinner line space and high productivity, and then diversifying to like a multiple layer of like RPCB. So we are expecting like a fourth generation sometimes on next year, which accounts for like a multiple layer rigid printed circuit. That's where we are right now. And then uh, from and from this year, we are calling for like a new project, so-called like a giga supply project. And then what what we are doing is like we are targeting to replace 300 million US dollar worth of the PCBs by 2029, and then we are call for the demand right now. So the scope of like this, I mean the project is not flexible printed circuit, which is like currently what we are doing mass production. It is like a rigid printed circuit, and due to like our recent material innovation, now we can print patterns on like FR4 based substrate in addition to the polymer, which is like a flexible printed circuit. And then this like a FR4 based substrate, like a rigid printed circuit, is widely used as of now. So in the many applications, such as like car electronics, TVs, PCs, and white appliance, and then various kind of like product, even for the industry as well. And then we are looking for the demand. And we only start code demand of this project since last month. But we already received like multiple companies are shown like their strong interest. And then we already secured like 10 millions of like MOUs and seeking more demands. So if you have any questions, and if you are interested in like this project, or like for general questions toward our technologies, please let us know. And then I've just put it on like my contact info here, this slide. And then of course after this meeting, or like even like from like Q&A session, I'm the more than happy to hear about all the questionnaire from like today's attendance, and for other separate meeting as well. Yeah, thank you so much for listening, and sorry for like a quick introduction of our technology.
Thanks so much, Satoshi. That was great. I love the just how many products use printed circuit boards, and the opportunity to decarbonize and reduce the environmental footprint of so much of the economy. So it's a fantastic technology. I have a couple of questions for me, and then please everybody feel free to put your own questions in the Q&A.
Yeah, thanks so much.
But the questions we have are, why has Elephantech succeeded really in this mass production for the flexible printed circuit boards?
Okay, yeah. The reason is that because all the technology parameter necessary for the inkjet printing is in-house. So that's the reason why. So I believe like there are like a lot of like players who are focusing on like ink or like inkjet printed head or like equipment, but there is none of them like have like every single element of the inkjet printing in-house. So that's the reason why. Because like for example, like if we change like parameter for like ink, then that affect like equipment and then also for the other processes as well. And if we change this parameter for like let's say process A, then we need to take a look for the process B and C simultaneously. So if like only like there is a separate players for like technology A and B and C, and then it's impossible to do like a simultaneous like adjustment. And then through like our R&D, there are like tons of like a small pivoting in middle. And then we unable to like a pivot of like our technology like a very like a smooth way because all the element in-house. So that's the reason why I think we could like successfully down for the mass production.
That's great. It's a very streamlined system, and you can uh, really continue to refine it, which you're
Exactly,
doing. Yeah, with
exactly,
the
exactly, exactly.
Hmm.
And then also like all the like a necessary partner is already our share stakeholder. So for example, like inkjet printed head is coming from like Seiko Epson, and Seiko Epson is a global leader for the inkjet. I mean inkjet printed head. So that's like a Thai partnership with Seiko Epson enable us to do it. And also for the chemical part, like we have like Ajinomoto, Shin-Etsu, and also like Mitsui Chemical in our share stakeholder. So we can do like a collaborative project together with them for like even for the material part as well. So those part open innovation partnership with like outside of the company is also one of the key to succeed like this project.
It's great, and I think that's one of our mantras at Climate Hive too, is just the importance of partnerships and making
Right, exactly.
connections. Yeah.
Exactly, exactly. And then that's the reason why I'm here because, honestly speaking, like last from until like last 2 years, we are more like a domestic company. And then now we are actively seeking for like a partnership with outside of the Japan. Of course, US is one of the biggest market for us. So and we are very open-minded and we are very actively looking for like a partnership and also for the customers. So that's the reason why like I'm attending this webinar as well. So
Well, and we would certainly wish you the best. It's very needed. I want to go to a second question here, which is,
yes,
uh, what kinds of applications
uh-huh.
are you targeting with the rigid PCBs?
Yeah, great questions. Let me if there is some good detail. Okay. Hold on. So basically, sorry, like I couldn't find like a right. Ah, yeah, here you go. So basically, I mean the laptop and the TVs are like one of the biggest like a consumer for like a rigid printed circuit and also like car electronics. So those are three main product using RPCB. But again, like RPCBs, like rigid printed circuit is a very diversified um applications. So almost all electrified devices using a PCBs. So but yeah, so that's the current situation is. And then but if we take say like a specific product, which is like a TVs, quite appliances, um, car, car electronics, and PCs.
And if I remember right, in our earlier conversations, the flexible ones can be used in new curved monitors and
Right, 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 right,
yeah,
right,
right?
right, right, Right. For the flexible one, so majority of the flexible one is using for the smartphone, but also like there's another industry using it for like, for example, like PCs. For the connection between like a LCD panel to like actual board, there is like a flexible printed circuit using, or like a PC backlight, LED backlight module, they're using flexible printed circuit. And even for the car industry, they're using flexible printed circuit for the lamp, headlamp, switches, handles, and even for the gearbox, and also sensors as well. So there's a variety of like a usage for the flexible printed circuit as well.
Yeah, as you said, the PCBs are in everything these
Yeah,
days.
exactly.
Now, what are here we have some numbers, right, of the
Right,
carbon footprint.
right.
So what with your product are some of the quantifiable environmental benefits uh, of your using, say, the pure additive process compared to
Yeah,
traditional methods?
thank you. So this is like a statistics using like I mean LCA calculation for the our flexible printed circuit. So for the carbon footprint, it's around like 75% reduction that can be possibly done. And for the rigid one, numbers will be a little bit smaller, but we are expecting 50 to like 60% reduction. But we are still on the phase of like R&D, so we cannot guarantee the actual number. But theoretically speaking, it intuitively is thinking like if like I mean, yeah, there is no removal process at all. So intuitively is saying that there is like a limited like raw material waste, and then we can that leads to like a direct impact to like a carbon footprint reduction.
And I see the water usage is also just huge
Yeah,
when that goes down.
exactly. Because the process is very short. That is the reason why. And also we don't have like any chemical processes besides like plating. So that is the reason why. For the conventional methodology, like there is a lot of like chemical process, for example, like development, etching, and stripping, and then all the process in between is necessary for like washing. So here is a more like a detailed slide there. Yeah. So the left hand side is like a subtractive method, which is a conventional method, and right hand side is our methodology. And this like blue line is a blue line is the one for necessary for the washing. So as you can see, and then the purple one is more like a chemical processes. So as you can see, like there's a lot of color here for like subtractive method. On the other hand, like pure method is like only like a limited part for like a washing. And for the using like a waste liquid, there's a lot of like toxicides like a material for like subtractive method, whereas like our pure additive method is more like a simple, like a just water or like a liquid water. Yeah.
That I yes, I am passionate about water and conserving water supplies. So
Ah, yes, it's
this
nice.
is huge. Can you speak so actually are there any uh obviously it's a very large printer that you were showing earlier, and
Right.
a lot of the PCBs are relatively small in electronics, but just for you, are there any limits on the size of PCBs that you can create using this technology?
Oh, that's great question. Right now, it's limited. That's right now it's defined by like a stage of like inkjet. I mean the printing. Like a stage. So on the top of the stage, we are doing like inkjet printing like this. So like it's limited from like a stage size. So right now we are our size is like 100 500 times like 830 millimeter. But this stage can be expanded as well. So if like there is a demand for like a larger like a size of like a PCBs, we can do it. So for example, for the in the car industry right now, like there is a flexible large. flexible printed circuit is using for like a battery, for using for the securing sensoring purpose. So sometimes like their requirement is like let's say 2 metal or like 3 metal even. But and if there is some demand, we can certainly do it. Because like our printer is using like component by component level development. And what I'm saying is that we can expand the size of the stage, and we can do like a customization. So if there is some like a demand for like a client side, we can certainly do it. So that's the question. That's the answer to your question.
Great. So it sounds like you can meet a lot of needs, a
Yeah,
lot
so
of
we can
different
do like a
customer
custom
needs.
out of the customization if there is some strong demand.
Great. And then can you speak to uh, just issues of durability, reliability, and performance
Oh,
of your
great
PCBs
question.
compared to
Mhm,
conventional ones?
mhm. Yep. So that this slide shows, we pass all the quality tests requirement, which is standard by like IPC. So IPC is the one for the organization which is defined about the quality standard for like this, I mean electronic component, and then we are like complying like IPC standard. So we are expecting one of the like international project with some customer, and then that's required about the following IPC rule, and then we are following it. And then for the already mass produced in the in Japan, that's followed by like it's a kind of like a siblings of like IPC standard, but that's called like a JPCA standard. And then that's like a quality standard is almost equivalent to like IPC, and then we already have like a um multiple experience of it. And then for the rigid printed circuit, it's almost same like methodology. So we are on the in the middle of the development. We are about right now doing like a standard sample creation by us, using like in order to pass like all the performance tests standard by like IPC. And then once like we pass all like a tested item, then we start calling for like customers like actual design to do like more like customization phase. So that's how like we ensure like quality, and then we are following like a conventional methodology standard.
Great. So got the certifications and the standards going on.
Exactly,
Um,
exactly. ISO or UL, yes.
Great. And I think one of the last questions here is just big vision for your company. What role does Elephantech see for itself in the future of sustainable electronics manufacturing?
Yeah, great. Yeah, that's a great question. So as of now, like we our business model is limited to like component production manufacturer. But the reason why we start doing like inkjet printing in-house development and also process development by own is more like we would like to spread out our technology for the sake of like humankind. And then that's why like after like do like a tangible like R&D, we would like to do like some like maybe like a partnership or like even for like a partnership with like a conventional PCB manufacturer who would like to implement our technology so that more like we can meet more demand for the future. So we are considering to pivot our business more into like equipment and materials sales rather than just electronic component. But that's the reason why that one of the reasons why like we start electronic component is because we need credibility from like end user with quality and then also like our technology level. So unlike other like I mean the other area, like electronic components requires like a very high level of like quality, and then also like maturity of like technology. And then uh it was very difficult for us to jump in directly to the equipment and material sales without um electronic component production, which is like proving our technology in the market. So we are like on the phase shifting to like a material and the equipment sales to answer your question directly.
Yeah, and just it's kind of the story of startups, right? As you come up with
Exactly, exactly.
fantastic idea, R&D for 7 years, and now really the ball is rolling and expanding. Um,
Right,
well, I
right.
just want to wish you a whole, all the best with expanding and growing in the market and really helping to improve the environmental sustainability of the PCBs and all of our consumer electronics. Um, uh, just a final final question here is, are there any kind of key takeaways you'd like our attendees to get from today?
Okay. Yeah, thanks so much for your your encouragement. So the key takeaway is like our technology is available, and there is so I think like people usually think like hey like a PCB is like necessary for like a necessary component. People I think neglect like the fact that the PCBs are it's not like sustainable, but the way there is no replacement technology at all. So that's I think people's I think usual thought. But I would like to say like hey like there is an alternative for like a conventional methodology which is available already, and then that can be used for like a I'm the various kind of the tech I mean the applications already, and then that would be like a silver bullet for like for future electronics. And then the fact that like considering about the current situation, maybe next 5 or 10 years, even for the 15 years, like a scale, I mean the period, the conventional PCBs are not sustainable. Not only environmental part aspects, but also for the price and then also like supply chain aspect. And then now is the time to invest for the future demand. So that's what I would like to remain as a final note.
I couldn't agree more. Uh, well, thank you so much. Do you mind going to the slide with your email just
Sure.
as we close out so that people can get in touch that way?
Yeah, thank you so much, Alex.
Yeah. Thank you, Satoshi. Thank you, everybody who attended today. This we'll have a recording up on YouTube, and we'll be sending that out along with an opportunity to fill out a survey and get in touch with Satoshi. So thank you so much, Satoshi, and
Thank
uh,
you, Alex.
yeah, thank you, everyone.